video is about professional way of threat modeling. So we want to actually perform threat modeling for a donation platform. We want to think like an hacker, and we also want to think like what, like a defender, so that we can protect that donation platform from spam payments or from fake payments or from any kind of payments. You understand? That attacker may want to use. Sometimes attacker can use bot spam, they can use AI spam, they can use different kind of things. So we actually want to protect that particular donation page from what? From that kind of attack. So that is what is happening here. So if you are a junior cybersecurity, maybe you are just into cybersecurity, you can bookmark this and watch it later. Now the user is already inside the website. So as the user is already inside the website, it's going to fill the donation form. Then it's going to complete the turn, that is the bot checker for the donation page. Then once he fill it, it's going to click on donate. Then once he click on donate, you understand? Then the donation amount and whatever he has filled will be routed through another Cloudflare Edge, which is put to secure the donation page. So this one is going to validate the request. That okay, the amount the person put, is it real? I hope it did not pass the maximum amount. I hope it did not, you understand? So all those things. Then it's going to check for rate limit in case the user is trying to put false. And it's going to, there are some wire rules there too, to block maybe SQL attack, SSS attack, or HTML, or any kind of attack that want to come in. Then we also have bot checker, you understand? So which is the one that would verify the person is actually a human being. Then DDoS protection is already configured. Then it's going to enforce the enforce security in transit, which is MTLS 1.2 plus or 1.3. Then it's going to make sure that it forces that person browser, you understand? That person that is making the payment is going to make sure that it's going to force it to use HTTPS, so that hackers will not be able to downgrade it to HTTP. Then after that, once all these things are verified, then it's going to forward, you understand, forward to the API gateway, which is in our AWS. So at the API gateway, there are some security that has been put in place also. So in the API gateway, we have a custom domain. So this is the custom domain that the Cloudflare will connect to, you understand? So at this point, we have the total, you understand, we have the total, which we monitor the number of requests per second. Then after it passes this API gateway, then it's going to be it's going to be routed to Lambda. So it is at Lambda where the major verification will take place. So at the Lambda will receive the request, then verify the token, you understand, whether it is actually from the Cloudflare or not. Then after that, it's going to log every donation, every amount or everything, any kind of amount the person is trying to pay. It's going to log it into the CloudWatch so that we can get a record or alarm of payment or whatever. Then after it verify all these things, you understand, it verify its own security, then it's going to return the payment, the Paystack link, which is the original payment. So it's going to redirect the person to the original page where the person is going to pay. Then at this Paystack page, then the person is going to it's going to fill the form, then put his card and make complete payments. So and after that, success. So no issue. So the first thing I'm going to do is to just drag a rectangle here and drag it, then drag it. So this is what we are going to use. Then I can give it a color. So I can give it a color. Let me give it a light blue color. So this is it. Now, after we have done that, the next thing there is to start drawing our column. So we are going to prepare 5 columns. 1, 2, 3, 4, 5 for it. So we drag this first one, then we extend it. So we are going to draw 5, 1. So this is the first one. Then we can right click on this and duplicate to make it 2. Just leave little space between them. 2, duplicate, 3, duplicate, 4, duplicate, 5. So now we have 5 layers. But let me adjust this very well so that we have enough space between them. So adjust this. So now we have the 5 layers. So this one is the browser security. Then this is the edge security. This is the API gateway security and threat modeling. This is the Lambda security and threat modeling. Why this is the for the Paystack endpoint. So what we are going to do first is to label each of these zones. You understand? So we are going to label it. So the next thing there is to make sure that we have what we call trust boundary. So we are going to use a dashed line. So we are going to use a dashed line for what? For that. So let's change this line. Let's begin to change it to all those broken lines. So broken line simply means trust boundary, meaning that anything inside this list is within this boundary. So we are just trying to create boundary for each of them. So click on this to change it, then click on this, change it, click on this, change it, then click on this, change it as well. So now we have changed it. So we have each of these trust boundary. You understand? So we can change it. Now we can actually put name on each of them. So let's put a name. So for this now, this one is going to be internet zone, because it is this part that is actually facing the internet. So we can name it untrusted zone. So here we don't trust it, untrusted zone, because it's actually facing the what? Facing the internet. So we don't trust it. So any part that is facing the internet, we don't trust it. So that's why we decide to call that internet zone. So I can copy this one or duplicate it to the next one. I'm just putting it here and change the name. So this one is going to be the Edge Security. So Edge Security. And the Edge Security we are using is what? Is Cloudflare. We are using Cloudflare as our Edge Security. Then we can duplicate this. Sorry, let me give this color. So we can give this color blue. Let me give it color blue. So let me give it this color. So we can copy this. So duplicate it, take it here. Then for the third one, we have API gateway. API gateway. So, and this API gateway is our trusted zone. So say AWS trusted zone. So we trust it because we have control over it, and there's a shared responsibility between we and what and AWS. So duplicate and put it. So we have zone. So here we can call it compute zone, and that is you can say highly because it is serverless. You can say highly trusted zone. So it is the serverless. It is a Lambda that we're using, and it is serverless. So you can call it what? Highly trusted zone. Then here we can duplicate this. Then here we can call it external zone. That is third party. External, and that is what? Third party. So we say third party, and that is Paystack. That is Paystack. So that's that. So we can decide to go this maybe later. Sha. Now that we have created the 5 zone, so the next thing we have to do is to start with the with the internet zone. So this part now is the interaction between between the user and the browser. So between any attacker that is coming, we want to manipulate the browser to do something so that they can actually have access to the website. So that is it. So one of the first measure of security is the browser security itself. So now what are we going to do here? We are going to do is to divide this section. So we are going to divide it into 2 parts. So let me bring a line. So we are going to divide it into 2 parts. So now we have divided it. We can duplicate this. Just press Shift and hold it. Then you drag it. So that's how you move. So duplicate it first. Right click, duplicate. The one you duplicate, click on Shift, then drag it and move it to wherever you want to move it to. You can drop it a while and drag it to anywhere you want to put it. So this is it. Then we can also duplicate this, press Shift and drag it to anywhere you want to drag it to. So now, so we start labeling it. So yeah, we'll have user plus what plus browser. So we are going to use something to represent the user plus browser. So let me use something to represent the user in this place. So make it small. So I'm going to look for user. Just search for anything here. You can search for anything. It's going to make it for you. So I'm going to use the user. Just make it small. So that's enough as user. Then you can label it. we can say user browser plus console. So this is for the outside part. So now we are going to use the arrow to show the direction of how it is going to go. Then we can place number here to show the flow, the first thing that happened. Number. So let's use blue number 1. So what the user is trying to do here is the user is trying to just send. So let me add text here to show what the user is trying to do. The user is trying to send HTTP posts donate request. So that's what the user is trying to do. HTTPS. Good. So this is what the user tried to do there. So, and that is the stage 1 that happened. So what are the threats and control that will be in place? So we are going to add our threat and control under it. So let's add our threats. So first to add our threat, just come to entity relation, then look for any of these tables. Yes, this is okay. Then place it here and drag it down. And stretch it. So here now, we can call it threats. So this is the threat, and the kind of threat we are using, strike. So I think strike threat model. So here now, we give it a background color of red. Give it background color of red to show that yes, this is a threat. So color red for threats, color green for what? For control or defense. So that's it. So this same thing, I can also copy it and duplicate it and put it under. Okay, it can't contain. So let me drag this one a little bit. Then the color of this one will change from being red to blue. So we are going to use blue. Make sure that we use a deep blue that will be differentiated from these ones. So now we have threats inside and we have controls. So we can start adding our threat, and so we can just copy this, duplicate it, and paste it in other parts. Copy, duplicate it, and paste it in other parts. Need to stretch this. So stretch this, stretch this, stretch this, stretch this, then paste this. Copy and paste this, just duplicate it and paste. Duplicate and paste. Duplicate and paste. And see, we are almost done. Duplicate and paste. Duplicate and paste. Duplicate and paste. So for this, let me make it straight. Now the next thing is to just add another line here and copy this, duplicate this, take it here. Then this one we can name it as Cloudflare WAF and Untrusted. Cloudflare WAF plus Untrusted. So that's it. And decide to add any symbol under it. Anything like so Cloudflare. There's Cloudflare here, I think so. But there's cloud. So let me look for anything cloud. Something like this. Sometimes we can go and download Cloudflare and make it look real. Image from here. So import. Then it is under document Cloudflare. Okay, this is it. So this is the image that we got. Hope this is not too big. Just make it small. So we have added that. Then we can now add a broken line that shows. So we are going to add this one here. Okay, good. Now we have this in place. So we are now going to duplicate this as our number 2 and put it here straight away. Just shorten it. So this is going to be our 2. So let me add number. Okay, let me finish duplicating this first. Duplicate this, then move it, click on it, click on shift, then move it. Good. Duplicate this, move it. Hey, sorry. Just shift and move it. Then let it touch. So it is bending. Good, straight. So duplicate this, then move. Hey, move it, shift, then move. Then duplicate this, then move. Good. So let me adjust it a little bit. Okay. So the flow is complete now. So the next thing just to number it and see how the flow is actually going. So I'm going to number this. So number. So number 2. This is 1. This is 2. Then we have 3 here. 2. Then we have 3. We have 3 here. Then we have 4. We have 4 here. Then we have 5. Then we have 5. So let me copy this. So number 4. Then number 5. So we have labeled our flow. Good. So the next thing there is to put our API gateway symbol. Just copy this, label. Let me duplicate it. Then paste it here. Then we label it as API gateway. AWS API gateway. So let me look for symbol that can represent that. What symbol can we use to represent that? So gateway. Gateway. Yes, this is API gateway. Good. So now we have compute. So this is going to be AWS Lambda. So copy this, duplicate it. So we have AWS Lambda. Lambda. So I'm going to use a symbol for Lambda. Lambda. I think we have Lambda here. Yeah, there's Lambda. Is that we use this or we use this or we use this? So because it is obvious, let me use this. I should use this. No, let me use this. So just make it short and drag it there. Duplicate this. Change the name. Paystack. Gateway. There was symbol. Let's just use any symbol that I'm not sure. This will cannot Paystack. Hey, let me just use pay. Anything pay. Involve money. Pay. Let me use money. Payments be okay. Payment is okay. As the symbol. So we are done. Then the next thing is just to start putting all the inputs, all the threads, and the stuff that we need to put. But we need to talk about this flow as well. How this flow is actually going. We need to put. So we have put comment for this. So we need to put comment for others as well. So duplicate this and put it under this place. So what can we say about this? This is forward valid request. So forward valid request. So after the Cloudflare check, it's going to forward valid request. You understand? Then after I forward valid request, so it is also this forward valid request that will also be able to get into this place. So any request that is not valid would have been stopped by Cloudflare. And duplicate this as well. Then at these points that we have Lambda. So here now it's going to invoke Lambda. We're going to invoke Lambda. So invoke Lambda. It's going to invoke Lambda to do what? To do is verification work. After it invoke Lambda, let me duplicate this. Then payment completion. This is where they will now do the payment completion. Payment complete. So that's that. So now it is high time for us to do the actual threat modeling and put the correct control there. So what we are going to do is that, okay, let me drag this so that we can see it clearly. So now what we are going to do basically is, for the first threat we have here, we need to first look at the scenario. What scenario do we have here? What kind of scenario do we have? Here now the user is trying to interact with the browser, you understand, and the tussle is present. So what are the threats that may likely happen here? The first threats I suspect that may happen is spoofing. So spoofing, and how will the spoofing happen? The spoofing can happen when maybe hackers, they try to fake the donation page of this particular web app. So they can spoof the domain of the donation page, such that they'll make it look as if it is actually real. So that is it. And what is the risk impact of this threat on the organization or the customer? So this one is high. This one have high impacts. This one have high impacts. So the second one Another threat we can notice here is that if at all they get to the web page, so they may try to change the amount, and that is tampering. They may decide to change the amount. So they will just change it. They may change it to maybe 1,000 naira, and it will look as if they are donating maybe 10,000 naira or more than that. So they may try to, like, you understand, to fake payments. So that is tampering. Tampering. So, and what they will do in tampering is manipulate amounts. Manipulate amounts from their dev tools. They can just use the browser and manipulate amounts. Change the amount to another thing. So that is it. Then what's impacts? What is the risk of this one? This one is what is a critical one. It's a critical threat because it's going to cause loss to the organization. The critical one. The critical one. Imagine somebody manipulates and say he donated maybe 5 million, whereas he only donated 1,000 naira. So he can actually sue them to court and say, where's the 5 million I gave you? So that is it. So they can manipulate the amount. So it's very, very critical. It has huge impacts. So risk assessment is based on the impacts and the likelihood to happen. So this one is likely to happen and it has a huge impacts. So that's why. Then the third one is information disclosure. Yes, this one is from we can have information disclosure. Information disclosure. Disclosure. So it means that the attacker may try to review, you understand, or get the tonsile token so that he can use it to, you understand, to bypass the security that has been put in place. So this particular token. So what's the risk is this one? The risk for this one is critical. This one is also critical because it can cause, because it has huge impacts and it can cause a lot of financial mistake, you understand, or financial loss. Because once they're able to capture it, they'll be able to bypass all the security measure and they'll be able to spam payments or, you understand, manipulate different things. So that's it. So now what are the control that we can put? So it's actually calculator ish. So now what are the control that we can put for each of these threats? What are the control we need to put? For spoofing, whereby the hacker try to fake the donation domain or donation endpoints. So what can we put in place to do that? Do is anti-phishing campaign, anti-phishing education or campaign. Plus, they can also do the mark. Yes, the mark or the king for the domain, so that they will not be able to spoof it. And they can also do brand monitoring plus brand monitoring. So they need to monitor their donation page endpoint. They need to monitor it in case somebody is spoofing. They should get alerts, or in case somebody is trying to, you understand, brand himself as the organization donation page. So they should get an alert on that. So they need to monitor their brand very well. So what does this control? This control threat 1. So we can just say T1. So that's what this one control. So number 2, for the second one, manipulate amounts. So if an attacker can manipulate the amounts, what are the things that should be in place? What are the things that should be in place? So there should be server side. You understand? Server side transaction validation. So server side transaction validation. So they need to validate. Sorry, I need to make this. So there should be server side validation. So that is going to validate the amounts, and that's what we have done in the Lambda. So in the Lambda code, the Lambda will surely validate the amounts. So there must be that, and in the code, the developers too, they must be able to validate so that is it. So this one is control for threat 2. So we are mapping the threats. We are mapping what the control with the threats. So the third one here, information disclosure. Like if token is what is disclosed, it's going to cause a lot of serious damage. Is a very critical one. So what control should be in place? So what they should do is short life token. So short life token now, the Cloudflare already has already have this. So within 5 minutes, the token, you understand, the validation token will expire. So that is it. So this one is actually for thread 3, T3. T3. So that's that about that. So this one has been solved. So let's go to the second part. But before that, let me expand the second part. Here we have the cloud WAF, meaning all the security we have put in the cloud. Here, WAF. Then plus the what plus the tonsil check. That's the robot. And it is all the requests you understand that come from this place, which is the endpoint. I'll be able to route, and the Cloudflare WAF will what we check, we check. So what are the threats that may likely happen here that an attacker can actually perform in this place? So for this now, what attacker can do here under this edge security that we have this is that they can do spoofing. So spoofing can occur. Don't forget we are using strike threat model. And what kind of spoofing can occur? So the kind of spoofing that can occur here is bots. They can use bots attack, plus they can use AI attack. They can use AI to attack. They can use IP spoofing. Yes, they can spoof an IP spoofing. And what is the impact of this? The risk for this is critical because it can damage the whole organization. Critical. Imagine they use a DDoS attack, DDoS bot attack, or they use AI bot attack. So they are going to damage the whole thing. So and it's going to affect the organization. So that's why it was critical. Don't forget, risk score is based on what the impact and the likelihood to happen. So it's likely for this to happen. So that is number one. Now number two is they can also try to tamper, like they can try to inject the header. So tampering can also happen here. So such that the attacker can what? They can perform header injection, requests header injection. They can perform request header injection. So meaning that they may look at the header and inject it with maybe XSX or maybe iframe or any kind of command injection. They can inject it there. You understand? They can perform idle. They can perform different kind of injection attack on the header. So this one too is critical because it can affect, and the likelihood is also there. Then number three, another thing they can do is they can perform DDoS and volumetry attack. DDoS attack plus volumetry attack. So meaning that they can flood, they decide to flood the donation page with a lot of fake or unnecessary payments. So that is it. So what are the controls that we are going to put in place to prevent this from happening? So this one is high. It's high because Cloudflare can actually block any kind of DDoS attack. So it is high. So what are the controls that may likely happen? So what are the controls that we need to put in place to prevent this from happening? So for the spoofing, which is bots attack, AI, then IP spoofing, all those things. So Cloudflare bots, tonsil can prevent that. So Cloudflare bots plus tonsil can prevent that from happening. That is for T1. That's threat 1. This one will block threat 1. So Cloudflare bots management can block any kind of then tonsil we also block any kind of bot attack or AI attack. Then number 2, for tampering request header, if an attacker tries to tamper or forge the request header to inject the donation page. So what we need to put there is Cloudflare WAF can actually block that. You understand? Cloudflare WAF can block that. So Cloudflare WAF and block that. So Cloudflare WAF rules will set rules using regex to block any kind of thing that we notice, or any kind of attack that may try to tamper with that. Also, we can set Cloudflare course. So Cloudflare WAF rules will what we block it. And input sanitization, yes, input sanitization, so we can block it. We block it. So this one will surely block C2, that is threat 2. Now for threat 3, so what can we use to block DDoS and wouldn't? Cloudflare will block it. Cloudflare. So Cloudflare already have all these things in place. So Cloudflare DDoS. So layer 3, 4, 5, 6, 7 will block it. So Cloudflare DDoS will block it. Then rate limiting, yes. Cloudflare rate limiting we also block it. Rate limiting. We also block it. Or threat 3, that's T3. So that is for T3. So we are done for the second one. So now, if an attacker tries to bypass this security, bypass this also, now it now get to the API gateway, which is AWS trusted zone. So what are the kind of attack that it can perform? What are the kind of things that it may likely do? What are the kind of things it may likely do, or it may want to do? So here now, the moment it was able to bypass any Cloudflare security, blah blah blah, blah, is actually exposed to what? To the API gateway. So he already have access to what? To the API gateway. This is what he's going to meet. So this one now, direct access to API. We have direct access to API, so you can manipulate, you can do anything with the API. But you already have the API. You already know, oh, this is the API. Oh, this is you already know. So this one now is very very critical, because with this you can manipulate any payment. With this you can control some things in the Lambda and validate its payments. So with this you can do a lot of things. So this is critical. That's high impact. That's high impact. Then number 2, then it can perform DOS cost attack. That's another thing it can perform. You may want to waste the company AWS resources or budgets. Maybe the company has budget that, okay, for this API now, maybe they are just spending within just $500 within 1 year. So you may try to perform DOS attack. You can use Ox layer 7 attack, or you can use Ox attack, or you can use any kind of attack, any kind of DOS attack to make sure that this API gateway overwork and exhaust their money. So that is what we call DOS cost attack. So this one now is high. The reason it is high is because it's not that critical. Because API gateway already has some features that can limit this. So we call it rate limiting. So API gateway, if it's configured, it will not cause all these things. So it is high. Number 3 thing that can happen here is that since the attacker have access to the API gateway, he can actually use the opportunity to also flood Lambda. You understand? He have access to the API gateway, so he can use the opportunity to flood. So whatever attack he do on API gateway will surely get to the Lambda. You can flood it. You understand? You can perform flooding and flood it of Lambda. So if Lambda actually allow it, you flood it. And this is just medium. It's not a critical stuff like that, just medium. Because Lambda also has its own control in place. So then what are the controls that we can put in place to mitigate all this kind of attack? So if an attacker have access to the API policy, to the API, if an attacker have access to the API, so what should we do? The first one is IAM policy. So IAM policy must be in place. IAM policies, very strong IAM policy, and MTLS. IAM policy plus MTLS can mitigate this. So meaning that if there is a strong IAM policy such that there's a least privilege, you understand, to what attacker can do, you will not be able to attack other. The MTLS, that is mutual transport layer security, meaning that the attacker need to show his certificate to the Lambda before he can communicate. So MTLS. So two of them must show certificate. And if attacker don't have any certificate to prove, you will not be able to have access to the Lambda. So that is it. So this can control T1. That is threat 1. Number 2, for the DOS attack, DOS post attack, what they will do is just the API. We have API totaling. API totaling. So totaling will limit the number of requests that I can handle. Totaling requests, then there should be a budget limit too. Budget limits. So totaling and budget limit will block this then DOS cost attack. So organization will not have to spend much, and it will not exhaust their money. So this one we solve the problem of threat 2. And number 3, flooding of Lambda. So we can use rate limits. Rate limit can block this one. There's the features on the API gateway that can block the, which is rate limits plus cost limits. So the rate limit can be set to maybe 10 requests, you understand, per seconds. The burst limit can be set to maybe 2. So these two things we actually block that. That is T3. So I think that's that about that. So let's go to the major one, which is our serverless. So for our serverless, which is our Lambda, what kind of threat that can happen here? So if an attacker bypass this, they now have access to the API and to the Lambda itself. What are the things that it can do? They have access to Lambda, direct access to Lambda. So what are the things? What's that thing that it can do? What's that magic that it can perform? Number 1 there is that it can perform what we call malicious payload. Forgot to put it. This one should be spoofing. Spoofing can happen here, or tampering too can happen. So depend. But let me just put spoofing. So they can have direct access to API, which is critical. DOS. DOS is already under strike. Default DOS. Then flooding too is under DOS. This one is also under DOS attack. DOS. But this is like a repetition. Okay, that is DOS cost attack, while this one is DOS flooding of Lambda. Now, for the Lambda now, what are the threats that may likely happen for this Lambda? So what are the threats that may happen on this Lambda? So is that if an attacker has access to the Lambda, he may try to drop malicious payload, and that is tampering, so that he can escalate. Through tampering, he can escalate his privilege on the Lambda, or he may instruct Lambda not to check or not to validate anything again. So that's tampering. So may drop malicious payload. May drop Trojan to be controlling the Lambda anytime payment is made. So payload. So this is very critical. This is very, very critical. Because he can be in his house and be controlling Lambda for us. Critical. Then number 2 that can happen. I'm just trying to narrow it down to 3 threats. There are a lot you can do your own and get more. Then he may have access to secret key if our secret key is not kept very well. We have access to Lambda, so access to secret key, that's information disclosure. So that is access to secret key. So if you have access to secret key, can do a lot of things, because here you may get access to the Paystack key. If Paystack key is put, you may get access to the Cloudflare key. So you have access to a lot of SSL certificate and all that. So this is critical, and it has huge impact, especially if the key is not even rotated. That's another issue. So that is critical. Another thing there is can also perform cost-based attack. Yes, can perform cost-based attack here too. Cost-based DOS attack. And this is not critical. This is just medium, because the control is already in place. Medium. Lambda 2 has its own concurrency limits to do that. So if the concurrency limit on Lambda is actually in place, something like this may not likely happen. So what are the controls that we can put in place to mitigate this and prevent it totally? The control we can put for malicious payload is strict server-side validation. Strict server-side validation. Meaning that the code that will be in the Lambda must be able to validate any input that is coming. There's a strict server-side input validation, so that you not allow anything. So this one we control threat 1. Then number 2, for secret access, IAM least privilege. IAM least privilege. Least privilege. We prevent this. We prevent this. So this one we attack for 2, so that information will not be disclosed. So if the attacker even have access to the Lambda and he can't access, can't access the secret key that has been put in the secret manager. So IAM least privilege can prevent that. Then storing the key in the secret key manager, so can prevent that. And auto rotation of the key. A lot of things, a lot of measures can be taken here. But IAM least privilege can cover all. So this we tackle T2. Number 3. Then for cost-based attack. So here we are going to just, I've said it, concurrency limits. Concurrency limit on the Lambda. Limit on the Lambda, we control this. Concurrency limits, we control this. Or timeout too. Timeout too can control this. Concurrency limit, weight limiting, all those things can control this. So this one is for T3. So those are the control that can be for Lambda. Now the third party system. So if our stuff actually leave Lambda, the Lambda is now trying to redirect user to Paystack where they are going to pay. So what are the likelihood things that may happen as it's trying to redirect that particular users, trying to redirect it. So for that particular user would have selected this amount. So what are the likely things that may happen? Why is actually going to what? Routing to Paystack gateway. So that's what we want to take model here. So it means that for an attacker, it means he has been able to bypass all the security measure, or he follow another backdoor. So we want to actually manipulate payments before it gets to the Paystack. So the threats that is here now. So the first threat that we can see here is payment amounts manipulation. The attacker may want to manipulate payments in transit. So maybe they are put maybe 1,000, it may change it to 5 million. Or they are put so I may change it to, it may reduce it, so it may manipulate the payments. So that is tampering. So we will perform tampering there. So manipulate amount. And this is critical. This is critical because it will affect the organization. And it will also affect the customer as well. Number 2. Another thing the attacker may try to do is the payments that has been made, he may try to replay it. That's replay attack. So he may try to perform replay attack. So he's going to do spoofing. That's replay. We replay legitimate payments. And if I legit payment, we replay it. And this is I. This is I, because there is already security in control to protect that. Other attack can you perform? Yeah. So we have said can perform tampering that manipulates amounts or credentials or any other thing. What other things can it do? What other things can it do? What other things can it do? Replay attack. This one should be replay attack. So I'm trying to reason. We have to think. Can also perform. We perform DDoS. We try to perform DDoS attack here. That's time we flood. That's spam payments. Spam payments. It's just the impact is just medium because Paystack already have their own security and control to mitigate that. So the major one here is tampering. You can tamper the movement of the whatever that want to go into the Paystack. They tamper it. So that's the major one here. So let's just put the control. So for the control, for the first one, the control that will prevent that is TLS. So TLS 1.3 followed by HTTPS, meaning that it must be encrypted, and plus likelihood of MTLS, because this is the third party. If Strike endpoint allow MTLS, or somebody can generate what's it called, certificates of authority, so we can use it with what with AWS. So if it is possible, so MTLS can also work here. So that's mutual transport layer secure. So that will prevent that. And so this one we tackle tier, that is T1. Then for number 2, we have spoofing. So for spoofing now, that is the play attack. The play attack can prevent using, to prevent the play attack, we can use a unique ID. Unique ID. So we can use unique request ID, unique request ID, or IP whitelist itself. But unique request ID can prevent that, meaning that for every payment, so there'll be a unique ID for every payment. There'll be a unique ID, and that's once that unique ID has been made through the Paystack, if that unique ID come again, it will reject it. So you need an ID, or we can call it nonce request ID. So this one will block T2. Then number 3, for DOS, which is spam payments. So spam payments can be prevented by using WAF. WAF can prevent DOS. Yes, WAF. So WAF rules can prevent this. That is T3. So those are the control in place. So we are done with our threat modeling.